To start out, we're going to say what we mean when we say flying away in terms of kinematic quantities. We decided this is when the force of the electric field is greater than the gravitational force. In addition, we chose the length for a student's arm to be 0.75 meters. Okay, so now let's draw our free body diagram. To start out, we're going to have two people with a mass of 70 kilograms each, standing 0.75 meters away from each other. Also, there's a force of the electrons pushing them away from each other. While at the same time, the force of the gravity is trying to keep them together.
Now that we have our free body diagram, we can begin choosing which equation we need for this problem. We're going to use the equation for the force of gravity. It is force of gravity equals gravity constant times mass of 1 times mass of 2 over r squared. Plugging in our constants and givens, we end up with the force being 1.839 times 10 to the negative 7th newtons.
This number is important because the force of the electric field must be greater than it in order to be considered flying away. The force of the electric field is given by the equation Ke Q1 Q2 over r squared. Now we plug everything in again and solve for the total charge of Q squared. We calculated Q squared to be 3.39 times 10 to the negative 9 coulombs. And in order to find the total number of electrons, we take this number and divide it by the charge of the electron, which is 1.6 times 10 to the negative 19. And then we get the total number of electrons to be 2.11 times 10 to the 10. And that is how we solve this problem.